Hello, welcome to Impulse Mathematics. In this session, I am talking about limit properties and some mathematical problem. So, properties of limit. First, we have to know that what is the existence of limit. Previously said about that the left-hand limit and right-hand limit. So, if for a function the left-hand limit and right-hand limit will be same for a particular point, then we said that the limit is exist. Here we consider two function f and g such that limit x tends to fx and limit x tends to gx exist. Then limit of the limit of sum of two function is the sum of limit of the function. This is quite simple algebraic property, that limit x tends to a fx plus gx equal to limit x tends to a fx plus limit x tends to a gx. Similarly, for the difference, limit x tends to fx minus gx, then limit x tends to fx minus limit x tends to a gx. And for the product and also the quotient, here in the quotient we need to remember one condition, that limit x tends to a gx never be 0. That is, limit x tends to a gx will be non-zero, because if we divide this by 0, then this will be a indeterminate form. Apart from that, we have another property, that is, if gx be a constant function and gx equal to lambda, say, then limit x tends to a lambda of fx equal to limit x tends to a lambda f of x. So this will be quite important property. And for a polynomial function fx, if we consider a polynomial function a0 plus a1x plus a2x square and so on, so we can easily deduce that limit x tends to a fx equal to fa by just simply putting x equal to a, we get f of a. Now I consider here a problem from NCERT exercise 13.1 question number 11. So here limit x tends to a x square plus bx plus c divided by cx square plus bx plus a. We here see that numerator and denominator both the polynomial function, so simply putting x equal to 1, we have this, so we get 1 here. You can easily deduce that. Now I consider another problem here, so NCERT 13.1 question number 7. So here a limit x tends to 2 3x square minus x minus 10 by x square minus 4. Here you see that if I put x equal to 2 here, then denominator will be 0. So here in the solution, if x equal to 2, the given value of the rational function takes up the form 0 by 0, it will be indeterminate form. So we need to remove this 0 by 0 form. Now for this we factorize this denominator and numerator. So we get like that, x minus 2 3x plus 5 by x square minus 4. If we cancel out x minus 2 from both numerator and denominator, then we get limit x tends to 2 3x plus 5 by x plus 2. By simply putting x equal to 2, we get the value 11 by 4. So limit of trigonometric function. Before going to the properties, we need to follow a theorem, that is Sandwich theorem. This is very important theorem and quite interesting too. If x, gx and hx be real valued function of x in a domain of definition fx lesser equal to gx and lesser equal to hx for all x, if this inequality will be satisfied, then for a real number a, if we take the limiting value fx and hx will be same, that is L, then consequently limit x tends to a gx equal to L. This is the property actually. So the proof of this theorem is not needed. Now by using this theorem, we need to prove the following inequality. This is cos x less than sin x by x less than 1. To prove this inequality, we all know that sin of minus x equal to minus sin x and cos of minus x equal to cos x. Here it is sufficient to prove the inequality for 0 less x less pi by 2. This, if we consider this inequality, then in the figure of unit circle, that is the circle of radius 1, then here in the figure we can see that for the triangle OAC, if the angle is x radian, then this CD and AB will be perpendicular to OA. So if we take the triangle COA, then and taking the sector COA, that this sector, then the area of this sector COA is greater than the triangle COA. The sector is that the area of the triangle also included this portion, so it will be always greater than the triangle. And also if we consider the triangle BOA, then it will be always greater than the sector OAC, this sector. So if we put the value here, half of OACD, here the area of OAC and area sector OAC less than the area of triangle OAB. So if we put the formula of the area, then half of OA into CD equal to this and less than half of OA into AB. So if we cancel out half of OA from all of this, then we get CD less than X into OA less than AB. Now from COD, triangle COD, that is this COD, it is right angle triangle. So sin X equal to CD by OA. Now as therefore CD equal to OA sin X. Now tan X equal to AB into AB by OA. So AB equal to OA tan X. Now putting the value of CD and AB in here, we get sin X less than tan X. So if we divide this inequality by sin X, we can divide this because value of sin X is always greater than 0 if we take the value of X is greater than 0. Here we take the value of X is greater than 0, so sin X will be positive. We can divide it through by sin X, then this inequality happen. If we taking the reciprocal of it, we get cos X less than sin X by X less than 1, which complete the proof. Now by using this inequality, if we taking the limit as x tends to 0, then we get limit x tends to 0 cos x less than limit x tends to 0 sin x by x less than limit x tends to 0 1. So we previously proved this, we previously considered the sandwich theorem. So by sandwich theorem we can conclude this limit is 1 and this limit is 1, so this limit will be 1. Now from this we can easily deduce that limit x tends to 0 1 minus cos x by x equal to 1. This is another result. Now here I considers a problem, NCERT exercise 13.1 question number 14. X tends to 0 sin ax by sin bx, ab not equal to 0. At x tends to 0, as x equal to 0, the given function takes up the form 0 by 0. So we need to remove the indeterminate form. Now limit x tends to 0 sin ax by bx, if we write this like that, that is divide by x and multiply x, divide by bx and multiply bx, then ab will be here, and by the quotient property limit x tends to 0 sin ax by limit x tends to 0 sin bx by bx. So as x tends to 0, ax tends to 0, and as x tends to 0, bx tends to 0. So if we take that limit ax tends to 0 sin ax by x by this previous property, we get this will be 1, and similarly this will be 1, so 1 by 1, then the value of this is AB. So that's all for today. You can solve the another NCERT problems from book, and if you have any queries, then ask me in the comment section. I'll try to provide you as much as possible. So thank you for watching this.